Okay, good morning everybody. It's Saturday for me at the moment. Hopefully you're watching this on Tuesday. Um, so we're going to carry on with our partial fractions stuff today. Hopefully yesterday went fine for you guys. Can you just do a quick starter for me? Here I've got 11 over 15 is equal to a over 3 plus b over 5. Have a quick think about why there's a 3 and a 5 here and how it links to this denominator. Thinking about what we did yesterday. Can you guys, using the same method as we did yesterday, up to a point, can you try and find out what A and B is? Just pause the video and have a go at that, please. Okay, so hopefully what you guys did was you times through by 15, because that's what we did yesterday. We times by the denominator on this side. If you times this by 15, you're going to get 5 lots of A. And if you times this by 15, you're going to get 3 lots of B. Now you haven't got the x's today to try and kill stuff, but just by inspection, you could think, well, 5 plus 6 would give you 11. So A equals 1 and B equals 2 would be a solution. Therefore, 11 over 15 is equal to 1/3 plus 2/5. And you guys can check that 1/3 is 5 over 15. Yep, that's fine. Okay, so that's what we did yesterday essentially, but just with numbers. We're going to carry on using numbers for a bit to motivate what we're doing today and why we're doing it, because today we're essentially doing what we did yesterday, but there's a bit of a spanner in the works and we just want to investigate what to do with that spanner. Okay, so what I'd like you guys to do, similar to what we just did here, I'd like you to start thinking about whether you could do the same thing for 13 over 24, splitting that up into two fractions. Well, you may have noticed with this one, 11 over 15, I picked this one on purpose, and the reason I've picked this one is because 15 is a semi-prime. It's a semi-prime because it only has two prime factors, 3 and 5. 24 definitely isn't semi-prime. 24's got lots of factors. If we write all the factors down, let's not worry too much about them being prime or not at the moment. We've got 1 and 24, 2 and 12, 3 and 8, and 4 and 6. I'm going to get rid of this top row because something over 1 isn't really a fraction. So I've got these three options. So I'd like you guys just to pause the video in a minute and just try these different options. So 13 over 24 is, for instance, A over 2 plus B over 12. And see if you can come up with any options for these. So if you could have a go at that now, please. We'll start again in a couple of seconds. Okay, so I've done the first two quickly. 13 over 24 equals A over 2 plus B over 12. If I times 3 by 24, I get 13 equals 12A plus 2B. Hopefully you didn't spend too long trying to find some values of this because there aren't any. 12A is even, 2B is even. If I add two evens together, one thing's for sure is I don't get an odd number, 13. Similarly with this one, 13 over 24 is A over 6 plus B over 4. 13 equals 4A plus 6B. 4A is even, 6B is even. Well, 13 can't be the sum of two even numbers. You might be saying to yourself, or shouting at the screen, but I used a fraction for A and B. Probably should have mentioned we're looking for whole number solutions there. So sorry if you have found some fraction of A and B which works. Moving on to the last one, I've tried 2 over 2 and 12, 3 and 8, so let's move on to the last one. 13 over 24 is equal to A over, oh no, I've tried that one, I haven't tried, I did them in a different order, plus B over 8. And if I times through by 24 this time, I get 13 equals 8A plus 3B. Now this is good news because I've got even number and an odd number. Even and an odd added together gives me an odd number. So hopefully I should find some solutions for this. There's probably some theorem in the world which says that that there is always solutions for this type of equation. They're quite easy to see. 2 lots of this will give me 16. And if I take away 3 lots of 1, then I get 13. So that would be a solution to that one. Okay, so why on earth have I made you do this when we're obviously doing very algebraic things? Well, if I think about what 24 is, 24 in terms of its prime factor decomposition is 3 times 2 cubed. So it's 3 times 2 cubed, and if you look back through these, you've got 2 to the power of 1 there, you've got 2 to the power of 2, and you've got 2 to the power of 3. So there's 3 different options here. I'm just going to ignore these ones for a second. It's going to be explained as well why these are the way they are. But the short version of this is I can't really be clear which of these fractions I actually need in. And I definitely can't be sure which one before I start of the powers of 2 I need. The powers of 2 are repeating. I've got 2 or 2 squared or 2 cubed. And it isn't until I went through every option that I found an option that works. Because I can't be sure, what I need to do, or what I should have done, is actually taken all of the options at once. So what I should have done is this. I should have said 13 over 24 is equal to a over 3, because 3 is the first factor, plus b over 2, because it could be 2 and not something else, or it could be 2 squared, or it could be something which has a 2 cubed in it. Okay, it ended up being in this case that I needed the 2 cubed one. So in doing this, I've ended up coming up with all the different possibilities here. I'm not sure which ones I need, but if I times through by 24 this time, it's not easy to see because I've got so many. Well, that should be a D, shouldn't it? Because there's so many unknowns, but it does mean that I've got every single possible way of doing this. So, how does this translate to doing things with algebra? Well, let's have a go. So, if I've got 2x squared plus 7, and that's all over, there's my ruler, let's go with 2x plus 1 squared x plus 3. I've got a linear factor here, and I've got what we call a repeated linear factor here. 2x plus 1 is repeated. It's not just 2x plus 1, it's 2x plus 1 squared. If it's 2x plus 1 cubed, similar to this situation, then I would have the cubed option as well. So I need to make sure that I think about all of my different factors here. Could be that I've got a over 2x plus 1. It could be that actually I used 2x plus 1 squared. And obviously, my last one needs to be the x plus 3. Okay, so what we are going to do now is basically what we did yesterday. We're going to times through by this and see if we can find out what values of A, B and C are. So I'm going to let you times through and then start to see if you can think of some decent values of X. So just make sure you pause the video. Okay, so hopefully when you times through by 2x plus 1 squared, x plus 3, you've got this line here. Trying to start killing some things, you could start with x minus 3, for instance. So that x is equal to minus 3. 2 times minus 3, or minus 3 is positive 9. 2 lots of 9 is 18. 18 plus 7 is 25. And that's going to be, well, this is all 0 altogether. This is 0. And over here, in fact, actually, told you to write this in every time yesterday, and I'm not doing it myself. So 2 times minus 3 plus 1, minus 3 plus 3, plus b minus 3 plus 3, and plus c 2 times minus 3 plus 1 all squared. This all goes to 0, that all goes to 0, so I'm left with 25 is equal to c lots of, well, 2 times minus 3 is minus 6 plus 1 is minus 5, and minus 5 squared is 25. So that must mean c is 1. So similarly, we can try and get something else. How about now we let x equal minus a half. If I let x equal minus a half, and I do this, let's have the page back. So what have I got? I've got 2 times a half squared plus 7 on the left hand side is equal to, I'm not going to write all these out this time because I haven't got enough space. So the a part disappears, the c part disappears, and that's going to give me b is equal to minus a half plus 3. So if I do some stuff with this one, half squared, if I times by 2, well, the 2 and 2 cancel out in the first place, it's just left with a half, so it's going to be 7 over, oh no, it's going to be, try again. It's Saturday morning, this is going well. So this is just a half, half plus 7, 7 is 14 over 2, so this is 15 over 2. I really hope that's right. And b, 3 minus a half, or 3 is 6 over 2, take off a half, that gives me 5b over 2. Times both sides by 2, I get 15 equals 5b, and if I divide by 5, b is equal to 3. And that's right, that's good. Okay, so now we have a slight divergence from yesterday's procedure. We've already had one divergence, which is the repeated linear factors. So this idea of repeated linear factors, we have to do it this way. Because of these repeated linear factors, we also get a second problem, and that is when we're trying to find our third unknown. So at the moment, just try to pick my ruler up if you're wondering what all the noise is. So at the moment we've managed to get C and B, but we haven't managed to get our hands on A. And the reason why we haven't managed to get our hands on A is because the things that kill B and C both kill A. So we need to use what we've found out so far. So we know that we've got 2x squared plus 7 is equal to, I don't know what A is yet, so I've got A, 2x plus 1, x plus 3. Then I've got, I know what B is, B is 3, so I've got plus 3 lots of x plus 3. And C, I know what C is 2, C was 1, so that's plus 2x plus 1 squared. Okay, so to find A now, what I need to do is just pick a value of x. Now, more often than not, you're going to have some square bracket here. And so the easiest thing to pick is x is 0. And the reason for that is that basically you get rid of one of the terms inside the bracket, and so you just squared the second number. Most of the time, that's the best idea. So at x equals 0, that's 0 plus 7. We get 7 is equal to 2 lots of 0 plus 1, so I've got A, the first bracket just becomes 1, the second bracket becomes 3. This whole thing here becomes 3 times 3, which is 9, and this thing here just becomes 1. 9 plus 1 together is 10. If I take 10 off both sides, I'm left with negative 3 is equal to 3a, and so a must be negative 1. Therefore, concluding statement, 2x squared plus 7 over 2x plus 1 squared, x plus 3 is equal to, negative 1 over whatever the first one was, 2x plus 1, plus b is 3 over 2x plus 1 squared, plus c over x plus 3. And we're done. Okay, so I hope that's clear, and I hope it's clear for the motivation of why we have to do the linear factors. I hope this made some sense and gave you an idea for doing this. If you do try and do this without linear factors, it almost certainly won't work. So you do have to remember this idea. Try and remember this story about 13 over 24, and hopefully you'll remember to do this in future. Can you guys have a go at all of whatever the next exercise was? Exercise 1E. So can you do exercise 1E? Can you do all of the questions, please? If you get really stuck, feel free to email me, ask each other. Try and avoid using the solution bank on physicsmathstutor.com or whatever it's called. Try and ask each other first, because not only do you sometimes, well, hopefully you get some help with it, but also someone else gets to compound the learning by trying to explain something to you. If you're all blooming stuck, then email me, or if you can't, don't want to email me, then yeah, obviously use a solution bank. But in the first instance, try and help each other. Okay, I'll speak to you again tomorrow. Have a lovely day.